All right, continuing on to page 77, the next sequence. Now this is going to get into the weeds, I'm going to tell you that right now, but it's really quite a process, and this is, again, this is what makes this course a lab-based course, and it's also what makes this course acceptable at just about any other university out there. So hang on to your hats, here we go. All right, so page 77, the next sequence. Recall that low mass stars have less gravity due to mass. Two. So the star then cools and compresses. Three. The carbon-oxygen core becomes degenerate. Okay, now we talked about degenerate material, degenerate electrons. All right, so this is where we get into a little bit of just a touch of quantum physics, the Pauli exclusive principle, which in cheap sloppy language says that electrons and all other subatomic particles, they are no-touchums. So if you have degenerate material, that means that you have compressed this material to such a point that it's moving so fast to avoid touching. Now we've even got some material that's moving at relativistic velocity here. So that's what's going on. We've got some pretty exotic material happening here. So we have a carbon and oxygen core that is now degenerate, and free electrons provide repulsive force. The core temp drops below below 100 million kelvins. Which means that helium fusion stops. Then we get a slight rise in temperature due to the compression, and that restarts the triple alpha process. We have helium shell flash. And fusion spikes. All right, the star expands, which makes sense. The star expands, and you have a brief decrease in shell temp. All right, and during these fusion spikes, helium shell energy can increase by a factor of 1,000. The star goes through several of these spikes. And they're separated by roughly 100,000 years. Which in astronomic terms, obviously, is pretty fast. So the star is, at this point, it's pretty much guttering out. Ten. The outer surface cools enough to allow electrons and ions to recombine. This recombining process emits photons. Remember, what are photons? I won't say it on the camera because this is going to be put out for everybody to see, but you know what photons are. We've talked about this. All right. So this recombining process recall that ionizing absorbs photons, deionizing releases photons. We have an electron in an excited state, and to go back to that ground state, it has to dump energy. How does it do that? It emits a photon. So again, we know what photons are, but that's for another discussion. All right. The photons do create pressure. Recall that photons are massless. But do have momentum. The pressure decreases until Pressure stops in the shell. So pressure decreases. It's over here. Pressure decreases until pressure stops in the shell. Core fusion long gone. And the ejected material cools. Condenses to dust grains. Okay, we're not done yet. We're just done on this page. So we'll pause to go on to page 78.